The second event was the successful dream Charles Lindbergh made come true. In his single-engine Ryan monoplane, Lindbergh had flown the Atlantic non-stop to Paris. 2 weeks later, carrying Charles Levine as a passenger, Clarence Chamberlain flew the Atlantic and landed in Germany.
First of all, we were trying to beat Lindbergh away. And second, we had to keep our plans a deep, dark secret because we had overheard Mrs. Levine say, if I thought my Charlie was going in that airplane, I'd burn it up. We finally got away about 6 o'clock in the morning on the 4th of June, 1927. The first 1,000 miles to Newfoundland was through was good weather. The only trouble was we had headwinds. And our tests on Long Island showed that we could fly for 40 hours at 100 miles an hour. Well, on the flight up to Newfoundland, we were only making 70 miles an hour. And 70 miles an hour for 40 hours is 2,800 miles. It was 3,200 to land on the other side, leaving the last 400 to swim. Well, fortunately, the wind shifted after we left Newfoundland, and as you see, we made it.
Lindbergh's lonely adventure gripped the imagination of the world as one of man's most dramatic achievements. The nation turned from its casual cynicism to make the shy young pilot, together with the airplane, a shining symbol of the horizon still beckoning for conquest. A vital factor in the ascendancy of American aircraft had resulted from the work of two companies concentrating on the intensive development of the radial air-cooled engine.
In this country, Charlie Lawrence was the first one to go into the air-cooled side and did some quite good work. His products being eventually taken over by the Wright Company, and it was really one of his engines after a couple of major designs, and they were really major designs, but one of his engines that powered the Lindbergh flight. Following this came one of the best of all of the power plant engineers, George J. Meade, with his famous Wasp and Hornets, which set up a new standard. These engines had built-in superchargers and just about all the modern features. In fact, they are fairly representative of today's engines. Along with this came another of the major developments in the power plant, that is the turbo supercharger. The turbo supercharger was really quite a long time coming. The Frenchman by the name of Rateau had originally started to try and get it, but it took the General Electric Company and Dr. Moss to get this thing, which made almost all the difference in the world.
The unusual engineering accomplishments of our American aeronautical industry began to bear fruit in the late 20s and early 30s. From a military point of view, for the first time, our various types of combat planes were unmatched abroad. Moreover, we found the solid beginning of commercial air transport.
I remember very well in one evening when Lindbergh and I were sitting in a small restaurant in Cuba, which we reached at the end of a Caribbean flight, and using the menu for paper, we made sketches of a transatlantic clipper. That was back in 1931. A few years later, the transatlantic clippers have been produced, created, proved success, and as at present we know that transoceanic flying is perfect routine, perfectly self-evident part of our modern life.
Jimmy Doolittle pioneered transcontinental non-stop flights.
In 1922, I flew from Pablo Beach, Florida, near Jacksonville, to San Diego, California, a distance of about 2,200 miles in 22 hours and 20 minutes. In 1931, I flew from Los Angeles, California to New York in 11 hours and 15 minutes. That first flight was the first time that the continent had ever been crossed in less than 1 day. The second flight was the first time it had ever been crossed in less than half a day.
Meantime, the Army and the Navy air arms were making fast strides in developing aviation. They were flying farther, higher, and faster. the Air Corps was perfecting its concept of the bomber as a long-range strategic weapon. In its exercises, the Navy was demonstrating the soundness of the carrier task force. Individual officers were exploring the use of new instruments and accessories and testing new theories to determine aircraft reliability. Two famous Army pilots, Carl Toohey Spotts and Ira Aker, flew 7 days in 1929 without landing.
The question mark flight was an endeavor to use refueling as a means of keeping the plane in the air for a long time. The driving inspiration behind it, I believe, was Ira Aker. On the course between San Diego and Burbank, we passed over the home of Mrs. Spott's father and mother. And every time he passed over, she would take my oldest daughter, who was then about 6 or 7, out to see us go overhead. And on the 5th or 6th day, she pointed us out to Taddy and said, "Taddy, there's your daddy up there. He's been up in the air for 5 or 6 days, for 5 days. Don't you think it's wonderful?" And Taddy looked up and said, "No, I think it's dumb." But the flight did prove that refueling was practical.
General Aker remembers an incident that forecast the need for equipment which would permit line flying.
In 1919, flying in the Philippines from Manila to Stotsenburg, our station at that time, I ran into a typhoon, and the rain was so heavy that I couldn't see the horizon. I fell in a spin, and only the fact that the Manila Bay was yellow and the rain was darker was I able to recover from the spin and fly home. To my surprise, I found for the first time that when you couldn't see, you couldn't fly. I described this to Lieutenant Longfellow, later General Longfellow in the Second World War, and we began some crude experiments by hanging a plumb bob down across the instrument board and by putting a carpenter's level on the longeron, and got so that with these two aids we could fly through cloud, through several thousand feet of cloud. And that was one of the early days of instrument flying.
10 years after General Aker's Manila experience, Jimmy Doolittle, in association with the Sperry Company, tackled the problem.
I made the first blind flight, the first completely blind flight, taking off under a hood, flying a prescribed course, and landing back under the hood without ever having seen out of the airplane. This doesn't sound very important now, but out of that came two instruments, the artificial horizon, the directional gyro, that are today standard equipment on every commercial airplane and every combat military airplane.
The chain of development led back to General Aker.
During the first transcontinental blind flight, Bill Kepner and I had a very practical but unexpected demonstration of the value of instrument flying. My ship was a P-12 with a hood over it, and a similar ship, a P-12, Bill followed behind as the safety pilot, so that he could tell me to turn right or left to avoid obstacles or other planes in flight. At one point, he was giving me rather repeated instructions, and I could tell by the water seeping under the cover that we were in a heavy rainstorm. Finally, he said, "Hold your present course steadily. I'm going to fly formation on you." And 4 or 5 minutes, he called on the radio again, and he said, "We've come through the storm now, and I can see again." During that period of time, you led us through because I couldn't see either.
The Great Depression had come. The industry was hard hit. But nevertheless, new companies developed to meet the increasing complexity of the airplane and its growing use of metals, electronics, and automatic controls. Dutch Kindleberger departed from Douglas to take over North American. Companies were formed bearing the famous names Bell, Fairchild, Northrop, Beech, Cessna. A World War Navy pilot, Leroy Grumman, left civil engineering to enter aviation.
We knew that a conventional airplane wouldn't get us an order. We finally ended up with the design of the first military fighter with retractable landing gear, for which we got a contract and which proved to be highly successful, having a speed far in excess of any current Army or Navy fighter of that time.
A pioneer aviation journalist, Earl Findlay, once went to see the Wright brothers' contemporary, Thomas Edison.
I asked if I could have a short interview with Mr. Edison, and you had to get up awful close to him. He'd put his hand up like this, saying, Mr. Edison, what do you think of the airplane? Oh, airplane? And this was after he had been talking to Foreman all morning in the biplane. never amount to a damn till they got to do it different. They have to have something like a hummingbird. Go up and go this way and come back this way, that way, this way, and come down, he said. Well, I tried it once. 'Tain't easy. And I got to doing something else. But somebody's going to do it.
But that's remained the opposite side of speed, namely the aircraft that could fly with no speed at all, that could take off from any spot and would not be in need of an airport at all.
The 30s also were the years in which each summer fierce competition was held to determine the best of the airplane breed. Proof of the individual airplanes, engines, and pilots came in the national air races. With thousands looking on, the legendary pilots raced. Doolittle, Hazlip, Turner, Whitman, Levere, Goulbach, Newman, Fuller, Jacqueline, and Cochrane. And flyers still flew against the clock, across the continent, across the seas, and indeed around the world itself. Balkan, Post, Gatty, Byrd, Hughes, Amelia Earhart, and wrong way Corrigan. As the hour swung late in the 30s, the air races were curiously American. For in Europe and Asia, aviation was not a case of relatively puny efforts in some, such as America was providing, much of it from individual man and companies. Rather, the vast resources of powerful foreign nations now were thrown behind the construction of air forces designed to subdue the world or to defend against such aggression. In the United States, under the impact of the Depression, Congress had scrapped the Morrow Board procurement plan and stopped providing appropriations for 1,800 military airplanes that had been scheduled. On New Year's Day, 1936, the Army Air Corps had only 300 planes fit for war duty. A year later, we had dropped to 6th place among powers in air combat strength, although our industry was judged to be technically at least 18 months ahead of foreign competition. Premier Daladier lamented, "If I had had 4,000 airplanes, there would have been no Munich." France had squandered a first-rate air power while she sat behind the Maginot Line. The British, too, had let the Axis powers outstrip them. Frantically, both countries turned toward the United States, aware that, in the very act of running hard to meet crisis after crisis, an emphasis had been placed upon research, experiment, and development, which gave the United States technically superior aviation equipment. So the free world turned to the United States, not only for airplanes, but all of those weapons embodying the modern arsenal. To expand its facilities, train workers, and to adapt its job shop operations to techniques of mass production took time. The tooling was still underway when Germany struck. Poland was shattered. Holland and Belgium were overrun. France succumbed.
gratitude of every home in our island, in our empire, and indeed throughout the world, except in the abodes of the guilty, goes out to the British airmen who, undaunted by odds, unwearied in their constant challenge of mortal danger, are turning the tide of war by their prowess and by their devotion, never in the field of human conflict, for so much owed by so many to so few.
Now the stubborn British stood alone. Over Poland, Holland, Belgium, and France, Germany's Luftwaffe had demonstrated that the airplane was a vital weapon of modern offensive war. In the skies above England, the Royal Air Force now demonstrated that the airplane was a vital instrument of modern defensive war. The struggle in Europe shook America. A month after Congress had received a bill providing only 61 combat airplanes for the Army Air Corps for the following year, President Roosevelt called for a long-range production program of 50,000 airplanes. America slowly mobilized its productive capacity. It began to draft its young men. It sought to train them with wooden guns, cardboard tanks, and mock airplanes until it could gear its productive capacity to build the real thing. The war spread. Germany seized Norway, turned on its momentary ally Russia, overran Greece, joined its partner Italy in Africa, and encouraged its Asiatic ally Japan. Nothing could have convinced the people of America more surely of the bitter nature of modern war than the sneak punch that Japan threw at Pearl Harbor. The nation fell to work to expand its token battle forces and its production into a great tide of men and machines. To train men and to equip them required long months, particularly in aviation.
Immediately after the President's pronouncement in 1940, licenses were given to the automotive group largely to assist in the production schedules which lie ahead. Nevertheless, until the end of 1943, the equipment which actually saw service on the various fighting fronts all over the world were furnished entirely by the aeronautical industry, because it was a fact that it required 20 months to 2 years for the average automotive company to begin.
With their momentum at full flood, the Japanese swept through the Pacific. Jimmy Doolittle and a little band of flyers carried the war home to them in a joint Navy-Air Force operation.
I've frequently been asked, what was the purpose and what was the effect of the first Tokyo raid? Well, the purpose was to take the war to Japan, to show them that their island was not inviolate. The effect? Well, the effect was to cause them to divert some of their military strength that was needed in the South Pacific to the protection of the home islands. The actual damaging effect was very little. Our airplanes were on the Hornet. We were intercepted just after daylight on the morning of April 18th, 1942, by Japanese surface craft. We took off immediately, proceeded to target, and all but one of the planes carried on to the coast of China. We carried 1 ton of bombs in each one of 16 airplanes. We dropped 16 tons of bombs on 4 or 5 different targets. When you realize that from the Marianas in the later stages of the war, B-29s were carrying as much as 6,000 tons of bombs, in one operation and dropping them on a single target, you realize how puny our effort was.
Slowly, the nation began to regain control of the air and the sea lanes that it had lost in the Pacific. The first great victory was the Battle of the Coral Sea. Captain Thatch, one of the Navy's ablest flyers and tacticians, remembers that battle and the subsequent Battle of Midway.
If you're going to apply the principle of concentration of force, for example, you've got to work with other people and have a good system of teamwork. I think that's one of the reasons why an attack by a carrier-based air group is so effective. It's almost a simultaneous thing, like a 1-2 punch in boxing. In the Battle of the Coral Sea, for example, the dive bombers and torpedo planes and the fighters came in almost simultaneously, but the enemy concentrated on the dive bombers. At the same time, that let the torpedo planes in, and they did most of the damage. On the other hand, in the Battle of Midway later, the enemy fighters concentrated on the torpedo planes, and the dive bombers came in almost unmolested. I could see them coming down like a huge waterfall, and there were practically no misses. They were the ones that did the job in the Battle of Midway.
With its growing stream of trained soldiers, sailors, and airmen equipped with improved weapons, the United States and her allies took the offensive. Rommel was driven from Africa. Sicily and Italy were invaded. From their bases in England, American bombers began to strike at the heart of Germany under the direction of General Spaatz.
Strategic bombing was one of the ways of winning the war. And our fighter operations, in a large measure, developed into covering operations for the bombers. In order to do that, we had to have the development that had taken place. Good radio, so the leader of the fighter outfits could not only talk to his own men, but be in communication with the bombers, and in turn get some guidance from ground control stations on the ground by radio. This resulted in a different type of fighting and a different type of operation. But it proved conclusively in World War II that the airplane had developed to such an extent that air warfare became a different war altogether than land and sea warfare.
Wellwood Beale, a member of the team of designers who created the B-17, saw the airplane altered from a defensive to an offensive weapon.
The conception of strategic air bombing was not fully developed at that point. Originally, for instance, the B-17 was built to protect our coast from an invading fleet, and hence it was called the Flying Fortress. But when we got to England, it was obvious that to use these bombers to the greatest advantage, that we would have to not only get the enemy's supply lines, but the places where he manufactured his military equipment. The British thought it would be easier to do it at night. They'd have much greater chance of success and would be less vulnerable to enemy fighters, and they called their bombing saturation bombing. They dropped large numbers of bombs on a large industrial area. The Americans, however, decided that with the B-17 and the B-24, that they could pinpoint a specific target. For instance, the ball bearing factory at Schweinfurt. They, in order to do the job properly, decided that it should be done at daytime, where their bomb sight was the most effective.
Step by step, the Allies began sweeping back across the reaches of the Pacific. At terrible cost, we took Tarawa, Saipan, Kwajalein, Guam, Bougainville, and the Philippines, setting the stage for the aerial assault on Japan itself. At home, the United States had channeled its great energies and its vast technologies to produce in flood the goods of war. And now, with our allies, our integrated sea, land, and air combat team attacked.
No one in aviation believes that aviation alone won the war. We do believe that the war might not have been won by ourselves and our allies, except that we had control of the air.
The massive, intricate, highly trained combat team that America had put together at a stupendous cost dissolved almost overnight. A free people yielded to a free impulse. They demobilized their men and discarded much of their equipment. In the field of aviation alone, they had built an incredible 96,318 airplanes in the war year of 1944. 2 years later, the production had shrunk to 1,669 planes. Where the civilian aviation interest had turned to stunting and barnstorming at the end of World War I, now the airplane had assumed the civilian role of a fast passenger and freight carrier. The network of airlines, which had sprung up in the 20s and 30s, was extended to every corner of the free world. 4-engine transports of ocean-spanning range sped millions of passengers across the continent and across the seas. The wartime DC-4 and Constellation were followed by faster, farther-ranging successors, DC-6s, advanced Constellations, Stratocruisers, and such twin-engine ships as the 202 and 340. In a time of spiraling costs, only air travel grew cheaper. From fewer than 6,000 passengers the airlines had hauled in 1926, they quickly rose to where in 1952 they carried 24 million passengers, 12 billion passenger miles. The Wright brothers' vision was still the goal of virtually all men in aviation, such as Robert Gross, whose industrial team produced the Constellation series.
Of course, it's obvious to, I guess, everyone that the airplane has been preponderantly military since its start many years ago. But there are signs, particularly in the last few years, that perhaps it wasn't always going to be ponderantly a military weapon. Man and science must go forward hand in hand. It can do a lot of things, this airplane. It can bring hundreds of millions of people throughout the world in intimate contact with one another. And contact with one another means understanding, and understanding in the end means peace.
Shannon and Tarrant with connections to Southern Europe, Africa, the Middle East, and Far East. Will all passengers kindly board their clipper through gate number 10. All aboard, please.
In the war's closing hours, Germany had employed guided missiles brutally, but without decisive effect. Simultaneously, England and Germany had put a few airplanes in the air powered by a radical new type of engine, the jet turbine.
The jet became really important in aviation. The accumulated engineering know-how that this country had built up with its piston engine equipment suddenly became very much less important. This event was really a great leveler in engineering background and potential for all countries. And we had to start over again to try to regain the supremacy which we had in World War II.
In their march across Germany, Russia had seized Germany's military tools and designs and many of the engineers who were developing the jet. The Russians now increasingly saw the Allied victory in which they had been a partner as largely their own. The Western world was either bled white by the war or demobilized. Russia and its communist allies alone kept their armies intact. Their whole creed was one of force, and they began imposing that force on Poland, Bulgaria, Romania, and Czechoslovakia. Russia's abrupt belligerence forced this country's attention upon the air power we had let melt away. For the third time in little more than a generation, the nation set about building a modern air arm. This one to be shaped around the fantastic speeds the gas turbine engine provided. Then, in 1948, when the Russians sealed off the land corridors leading to western Berlin, the United States, England, and France countered with the famous Berlin airlift. From their bases outside the Iron Curtain, a steady stream of airplanes flew night and day, supplying West Berlin's 2 million residents with food, fuel, and medicine. Finally, the communists capitulated and reopened the land corridor. Then they sent their minions into war in Korea. There, the United Nations chose to stand and fight. It was a strange, bitter, circumscribed war. The Air Force's prime striking weapon, its Strategic Air Command, was ruled out of bounds. The first sustained jet combat in history took place in a quadrangle of sky up to 40,000 feet above the earth, but always south of the Yalu River. Russia sent aloft a first-rate jet fighter, the MiG. Only the Air Force's Sabre from the United Nations array of fighter planes could match it. It was a war in which transport airplanes flew 7,000 miles to deliver materiel and to return sick and wounded men. And it was a war in which the helicopter, with its ability to fly standing still and land anywhere, did a multitude of jobs. Among them, transporting literally thousands of wounded from the battlefield to rear area hospitals for prompt surgical attention. Under the impact of Korea, the nation had begun again to turn out modern aircraft in quantities. Mundy Peel, the chairman of the Industries Association.
That we as an aircraft industry are at the present time turning out about 14,000 airplanes. At the moment, we are a healthy industry. We have to pour back a tremendous amount of funds into research and development, funds that we earn when we make the airplanes. This is a very healthy thing. It creates competition. We want competition.
Dutch Kindleberger, whose organization built the Sabre, pictures the sky 10 miles high as man flies at a speed approaching that of sound.
Today, we're flying at very great speeds and at very high altitudes. As a matter of fact, up in the area at which a lot of the fighting is being done, around 50,000 feet, we have a different world. It's a thin, blue, dark blue air. The sun doesn't shine so brilliantly because there's nothing to reflect it. There's no plane of reference for the pilots, such as hills or clouds or sky. In such an atmosphere as this, even a bomber is hard to see. And the trouble that we are facing, the future, is not the sound barrier. We know how to fly through that now. The thing that is bothering everybody is the thermodynamic barrier. The
air flowing over an airplane at these very high speeds by friction will heat up the surface of the airplane. As a matter of fact, if we go to Mach number 2, which is twice the speed of sound at sea level, the surface of the airplane will get hot very rapidly and will stabilize at about 500 degrees. Well, since ordinary aluminum alloy loses half its strength by 350 degrees, and that even titanium and steels begin to give trouble at 500 and 600 degrees, it's obvious that we are in a great deal of difficulty in the future. There also are many things like hydraulic fluid. We don't know how to make hydraulic fluid that won't boil away at this temperature. We don't know how to make packings that won't seize at this temperature, or bearings, or lubricants. In fact, if the bubble with which everybody is familiar gets soft and would lose its shape and disappear at 300 degrees. So we have ahead of us a great deal of research and a long, long time of trouble before we're going to be going anything like the speeds at which our magazine supplement writers seem to think we're ready for tomorrow.
Modern test pilots who fly at sonic speeds and incredible altitudes take an equally factual view of their calling. Tex Johnston sums up his philosophy after putting the J-57-powered B-52 through its paces.
After 12 years of testing, 10 years in the jet field, involving the first jet airplane to fly in this country, the P-59, the first rocket airplane to fly in the United States, the X-1, incidentally the first airplane to fly faster than the speed of sound, the B-47, the B-52. I believe all the more in the two old sayings. First, that one test flight is worth 1,000 expert opinions, and the other one for the flyboys, the altitude above you and runway behind you will never do you any good.
Chuck Yeager, the first man to fly through the sonic barrier, and Bill Bridgman, a test pilot who has flown almost twice the speed of sound and has piloted a plane at an altitude of 79,000 feet, discussed their calling in language peculiarly their own.
Certainly enjoyed the work. I think launching is the only safe way to get into that kind of flying. It's a heck of a lot safer than takeoffs.
Yeah, and you burn so much fuel when you take off before you get up to the altitude where the airplane can drop you. And I personally think that's the most fun involved in a flight is when the guy cuts you loose. You're just hanging there for a minute, just like on a roller coaster.
Yeah. You were pretty close to stall, too, when you came out of there, weren't you?
Yeah.
Out of the 29?
We stalled at around 240 indicated with full fuel load. So one time, I remember Jack Ridley, we had a release failure, and he dropped me out at about 180 indicated, and I didn't know which end was up for a while.
Well, I noticed on the skyrocket that when we first dropped out, you could kind of feel the stall by watching the boom out there. And the boom began to shake while she was on the nipple. I don't know.
You see it bend?
I see it oscillate a little bit, yeah.
And so the airplane has evolved from the Wrights, whose first flights at Kitty Hawk were at speeds hardly faster than an athlete can run, to speeds today where the Bridgmans, the Yeagers, and the Johnstons travel faster than a bullet. Horizons far beyond today's achievements still beckon.
Your name, sir?
Frank P. Long.
Have you flown before?
Yes, I've flown before.
takes a lot of people to get things started at Grumman, and a lot of people to keep things moving. Different people with different talents, experienced people, and some right out of school. Over 28,000 people filling a variety of jobs and engineering disciplines that no one could have imagined when the company first opened its doors over 47 years ago. During that time, Grumman has moved from pontoons and amphibians to anti-submarine and early warning aircraft. From the first Navy retractable landing gear to the first variable sweep wing. From the bottom of the sea to the surface of the moon. Wildcats, Hellcats, Tigers, and Tomcats. It's been a marriage of men and machines, integrating systems, managing complex programs, and meeting demanding mission requirements with dependable products like the F-14 Tomcat. This all-weather Mach 2 Plus fighter interceptor is designed to meet the enemy effectively at any altitude. Its unique variable sweep wing means low-speed maneuverability for close-in air-to-air combat and operational flexibility at high altitudes and high Mach numbers as well. Early radar detection and a multi-shot, multi-target weapon control system separate the F-14 from all other tactical aircraft. The Tomcat can deliver a variety of missiles from close-in to the long-range Phoenix missile and can fire up to 6 missiles at 6 different targets at the same time. As many as 24 targets can be tracked simultaneously. Manufactured primarily in the Bethpage plants, F-14 final assembly and flight testing are accomplished at the Grumman Calverton facility. Here, production continues round the clock as many hands work together to get the aircraft out on schedule and into the hands of Navy pilots. The F-14 is also in service with the Imperial Iranian Air Force. 80 of the twin-tailed Tomcats have been purchased by this dynamic nation in the Middle East. As part of the far-reaching Naval Defense Command, the F-14 joins another versatile Grumman weapon system in the fleet, the A-6E Intruder, an all-weather close-air support and attack bomber. First flown in the early 60s, the Intruder has benefited from a continuous program of product improvement, which has increased its overall effectiveness and versatility. In addition to its primary role as an all-weather attack bomber, various models in the A-6 series are used to suppress surface-to-air missiles, to refuel other aircraft in flight, and to assist in anti-submarine warfare operations. The A-6E model, with a new radar and computer, has proven particularly effective, detecting, tracking, and destroying enemy targets in any weather, day or night, without visual reference or any external navigation aid. The U.S. Marines use this aircraft almost exclusively for close air support. With the installation of an electro-optical system, the A-6E has the added capability of infrared target detection and laser-guided weapons delivery. The latest member of the A-6 family, the 4-place EA-6B, is the first aircraft built specifically for the electronic countermeasures mission. Its primary job, to jam enemy radar in defense of strike aircraft. The technology and systems integration know-how developed for the EA-6B is now being used in a manned tactical jamming system for the supersonic Air Force EF-111A. 2 F-111A fighter bombers have been modified to accommodate an updated ECM system with more automation in this, the first Air Force tactical system designed specifically for electronic countermeasures. Supporting the Navy's early warning defense system is the E-2C Hawkeye, a computerized airborne command and control center, which has added a new dimension to the science of gathering and coordinating real-time combat intelligence. With its advanced radar processing system, the Hawkeye can pick out small airborne targets hundreds of miles away, over land or over water, alerting defensive forces and directing fighter aircraft to the intercept. Getting the most out of production aircraft has been a hallmark of Grumman know-how, a combination of practical engineering and sophisticated design efforts. Another example, the Grumman Mohawk. 4 versions of this unpretentious aircraft have provided around-the-clock surveillance for the U.S. Army. The latest Mohawk combines all the reconnaissance capabilities of previous models through the use of photographic, infrared, and side-looking radar. Inspection, repair, and updating of Mohawks are accomplished at the Grumman facility in Stewart, Florida. In fact, there's a lot going on in Plant 77, including production of F-14 subsections, commercial engine pods, and spare parts. The old Grumman standby, the rugged Albatross, which first flew over 30 years ago, is also overhauled and refurbished here. Many of these amphibians are still in service with a number of foreign governments and the U.S. Coast Guard. Product diversification at Grumman extends even further to a military version of the Gulfstream 1 for training A-6 bombardier navigators, to the modification of 2 Gulfstream 2 aircraft for use as crew trainers for the Space Shuttle Orbiter, to evaluating the use of windmills and solar panels as a means of helping alleviate the energy crunch, to a revolutionary process developed by the research department for riveting through high-velocity stress waves generated by electrical energy, to the 67-ton Flagstaff, a hydrofoil ship which can fulfill a variety of military, coast patrol, defense, and search and rescue missions, to designing and building flight simulators for training personnel in handling aircraft systems. At Great River on Long Island, the company has set up an extensive facility for production of printed circuit boards, cables and harnesses for aircraft and ground support equipment. And in Texas, the Grumman Houston Corporation manufactures electrical and electromechanical components for aircraft systems, energy exploration, and oil refinery operations. Along with these varied products is an extraordinary Grumman commitment to outer space that began over a decade ago with an orbiting astronomical observatory. The Apollo space program, of course, added a new page to history with each flight. 9 times Grumman lunar modules were launched, and 9 times they responded in near flawless fashion, unmanned and manned, in Earth and lunar orbit, and finally, on the moon itself. The clean room where the lunar module was assembled has since been renovated to accommodate another space project, the Delta Wing construction for the Space Shuttle Orbiter, the first reusable space vehicle.
There she goes. Clear and beautiful. There, we got a GPC light, lost the test on 2.
Beyond these and the major weapon systems in production today are a number of commercial and smaller government programs. A subsidiary, Grumman Allied, handles manufacture and marketing of many of these products. In addition to the line of popular Pearson sailing auxiliaries, Grumman canoes, and utility boats, Grumman Allied manufactures truck bodies and a variety of buses, emergency rescue vehicles, some of which are in service with the New York City Department of Hospitals, fire engines, and a unique electronically controlled fire hose nozzle with a built-in radio transmitter that puts full control of the water stream in the hands of the nozzleman, providing the right water flow to the right hose at the right time. Among the more recent products is the Dormavac low-pressure storage system that precisely controls temperature and humidity to arrest the growth of bacteria. As a result, perishable commodities can be shipped in the aluminum Dormavac containers and stored for much longer periods of time, opening new worldwide markets for a variety of products, including food and cut flowers. Facilities for treating municipal waste are now being designed and constructed by Grumman Ecosystems Corporation. This subsidiary has acquired rights to the German VKW technology for burning solid waste to produce usable steam and electric energy. Diversification has also taken giant strides at the company's Grumman American subsidiary. Here at Savannah, Georgia, is the home of a number of commercial aircraft, including the Gulfstream II, the world's fastest business jet, with a cruising speed of nearly 600 miles an hour. The only aircraft in its class capable of non-stop transoceanic and intercontinental range, the Rolls-Royce-powered Gulfstream II also offers a spacious interior. Depending on individual decor, the stand-up cabin can accommodate up to 19 passengers in living room comfort. From the Gulfstream II to the four-place Cheetah is no small transition, but it represents the other end of the company's increasing interest in the commercial aircraft market. Other entries include the two-place T-Cat and Lynx, a family aircraft, the popular four-place Tiger, and the new twin-engine Cougar. Rounding out the Grumman American line is the Super AgCat, an agricultural biplane for spraying and dusting crops. This longtime friend of the farmer now has a 600-horsepower engine and a 500-gallon hopper available in the latest version of this seemingly timeless aircraft. In support of the Grumman Corporation as a whole and a growing list of commercial clients is Grumman Data Systems, the largest non-government computer facility on the East Coast. Here, Data Systems can simulate a space launch, supervise a complex telephone exchange, manage a corporation's total business system, track test flights with a real-time automated telemetry system installed at Calverton, and help establish standards for the maritime industry through simulation and computer-aided research experiments. An integral part of overall Grumman capabilities is a far-reaching effort aimed at meeting current and future corporate goals. Conceptual and preliminary design studies essential to staying on top in the aerospace business. On the drawing boards today are a number of new aircraft designs, from super agile fighters to vertical takeoff and landing vehicles, which will operate from small air-capable platforms in the new Navy of the 1990s. Space projects include a satellite system with a large antenna to be unfurled in space as a public service platform, a fabrication system that will eventually enable us to literally build large structures in outer space, and an orbiting satellite to supply practical solar power. Through the research department, the company is investigating scramjet technology, transonics, and supersonics, analyzing aircraft control systems, and simulating air combat maneuvers for tactical development and pilot training. Other research programs deal with studies in a zero-G environment, including experiments with NASA, using a series of sounding rocket flights to prepare for future space processing laboratories. Generating electricity from a new tornado wind turbine system. Developing sensor technology for correlating images from enemy targets to cancer cells. Devising more economical ways to enrich uranium. And applying the unique Grumman Foswich sensor detector in airborne exploration for uranium. Transfer and development of new technologies for use in military and commercial products is a prime responsibility of the Advanced Development Department. New manufacturing techniques developed here include the use of electrons and laser beams, the plasma arc, and ultrasonic energy. To meet the technological challenge of weight reduction, a problem common to all aircraft, Grumman is developing new advanced materials and processes, pioneering the use of boron and graphite composites, which are much lighter than current metal structures, stronger, and less expensive too. Efforts in this field, including automatic tape laying for the F-14 horizontal stabilizer, have paid off, with contracts for production of prototype horizontal and vertical stabilizers for the Air Force B-1 bomber. Most of the manufacturing of composites and reinforced plastics is accomplished at the company's facility in Milledgeville, Georgia, where over 2,000 aircraft parts are produced from composites. Marketing Grumman products, of course, is a full-time job within each corporate subsidiary. In addition, Grumman International promotes the sale of products and services in the world marketplace. Headquartered in Bethpage, this division of the company operates through regional overseas offices and wholly owned subsidiaries. And behind every Grumman product is a worldwide service network, providing test equipment, spare parts, technical publications, and the personal assistance of highly trained field reps, whose experience and dedication have often been the difference in keeping a flight scheduled or canceling. The company is long past the tin-knocking mass production days of World War II, when literally hundreds of airplanes rolled off the assembly line each month. Then, systems integration was little more than strapping a pilot into his seat. Today, it's different. The real test is to deliver a total system, to engineer, fabricate, test, and service it. People, of course, are the heart of the system, the one irreplaceable factor that makes it all work. Indeed, working together, we have a lot to offer, having grown in knowledge and experience, while continually encouraging a flow of new talent, new people, engineering, building, integrating, and managing systems that men have learned to depend on.